Welcome to Through the Corporate Glass, a podcast that explores career choices. We dive into the latest trends in tech careers, demystify industry roles, spotlight startups, and even explore unconventional paths outside the industry. Join us for authentic conversations that will challenge your assumptions and inspire you to think differently. Welcome to another episode of Through the Corporate Glass. I'm your host, Ashwini. Let's unravel the world of AI infrastructure. What does building an AI infrastructure product entail? And what's the role of open source and how is it a game changer? What skills are necessary to build a successful career in this space? And what has changed with the advent of generative AI? To discuss this and much more, we chat with Johnu George, Technical Director at Nutanix and co-chair for Kubeflow and AutoML Working Group, as well as the co-chair for the MLCommons Working Group. I work with Johnu on a regular basis and I enjoy it a lot. Apart from his in-depth technical expertise and incredible engineering skills, it's such a treat to work with someone who's a deep thinker and a great listener. Thank you so much for being on our podcast, Johnu.
Thanks, Ashwini. Awesome to be here and share some of the experience that I have.
Where did your career start? I know you started in the world of networking as well.
Yeah, fresh from college, there's a awesome startup that people used to talk about, and that was Tejas Networks. It was a pretty solid product built from India. I think that made my life change altogether from a technical perspective. I had awesome mentors who are really system C and talk about different aspects of systems, how to code, how to do reviews. And that was one amazing experience. I stayed for some time, and after that, I thought it's the right time to go deeper into systems. I had a very good base, and that was the reason I thought I should do something in the system. So I went into the distributed systems area, doing masters in US, and again, that was a very exciting journey there as well. After masters, I went with distributed storage, and that was very popular during that time. Ceph and open source storage was getting evolved, and I was participating in that, started open source, did some core contributions, then got opportunity to work on a logging platform, again a distributed platform, looking at different aspects of distributed systems. And that is when we were building that product, a logging platform, that was primarily on virtual machines. And we realized that that doesn't scale well, to a point where there were a lot many operations to be done whenever required. The Docker container announcement came, Kubernetes announcement happened after that, and it was the right time. So it's in 2015, right? We saw the need of having a container based platform, and we slowly started moving towards that. And that was the start of the next journey that I am in right now. So in 2016, we were adding some of the features to the platform in the machine learning space, basically to provide extra analytics and kind of figuring out what went wrong in the system, etc. And in 2016, there's a project started by Google called Kubeflow, and we joined from the very start onwards, right? And that time it was just TensorFlow, and Google was supporting that, primarily driving that project. So we actually wanted some platform on Kubernetes which can train and serve TensorFlow jobs, right? Build a TensorFlow model and then serve it using TF serving. And Kubeflow started with that. And over time, and it was a pretty popular framework. I think in very less time, it got to 5,000 stars. I think I would say in less than a year. Lots of contributions came, 100 plus companies started contributing. Many more projects got started. I was leading many of these efforts. And that's how this AI journey came in. And whatever which we do now is actually continuation of that.
That's fantastic. I mean, I think so many interesting points over there, right? And I completely agree. I feel like the first job that we take kind of shapes the direction in which we end up kind of doubling down. I know you mentioned Kubernetes, you mentioned Kubeflow, Tensor. flow and so on. So we will, for our listeners, make sure that we link enough in the show notes so they can go try and check out all of these technologies. That is very interesting to see that you started with core systems, went into distributed systems, and then made your way into ML and now AI. Can you define for us what AI infrastructure means? There's a lot of buzzwords out there. So how do we
Right,
define?
right. So at the core, to me, everything is systems, right? And on a larger scale, it is basically distributed systems. Now, for a decade or more, we were talking about DevOps and other things, but at some point, people figured out that that is not enough in the machine learning world. There are different phases of machine learning, be it from your data cleaning to training a model, doing experimentation, tuning, and serving, orchestration. So what do we do from an operations perspective, right? And what is the infra that can support these operations? And that's what we call an AI infra. But at the core, it's all systems. There is not nothing much different. But I would say AI infra is much more tuned to cater to the machine learning requirements and making it simpler for someone to start deploying and managing these workloads at scale.
That makes sense. So obviously, in the past few years, there's been a shift towards generative AI and large language models, right? Do you think that's impacted the infrastructure space in any way?
So I think that's also an evolution, in my opinion, because it started with the traditional predictive models where, like, take an example of image classification, where given an image, you predict it, right? But right now we have got into the generative AI space, which has its own challenges. Which is completely different from the traditional predictive model space. You have very large models. We are talking models which cannot even fit in a single node. You need multi-node inference, huge clusters for training these models. You need larger accelerators. You need a pool of accelerators to do something on that. So the challenges that we are having now is much different from the predictive models, right? And the best example would be in the generative AI space. It is very difficult to call or define a request on a fixed length, in the sense, at one instant I can ask, what, give me a summary of entire passage, and in the next iteration I could just say, whether can you say what does it mean, like which can give a one word answer. So in a second you can have a 10,000 word query, and in the next instant you can have a one word query, right? Purely from a systems perspective, these are very, very challenging to actually ensure that the infra itself is fully utilized and provide max throughput and at the lowest latency possible, right? And those are the key challenges that we are having in the Gen AI space, which we haven't seen in the traditional world.
Yeah, I completely agree with that. So, just to break down the different infrastructure components, and I'm going to very specifically do this just keeping systems in mind. So, for a second, like ignoring all of the large language model jargon, right? So, let's say we have an API server. Pretty much every system has an API server today to expose an interface. Then there is an observability stack, of course, which will vary depending on the platform, but you always have one. You have database management. Typically, you will have a database with the servers. And then there is, of course, aspects of how do you deal with these different components in an optimized way. Then you spoke a little bit about just how optimization is a little different and more difficult and challenging in the LLM space. But just in terms of these components, do you think there is similarity in the way we approach the overall system design for large language models? Or do you think each of these components have evolved to be better?
So that's a great question. So I think what you covered is right to a point, and right now I can see that the architecture is little bit evolving from there.
Mhm.
So yeah, as you said, there is an API gateway which used to handle all the incoming requests and then get onto, and there's a database management system which will take care of all the state nature of your the entire system. you have a stack which will do all the monitoring and ensure that you have the best performance out of that. So it all remains same. What I see right now is more AI oriented architecture where there is a concept called AI gateway where many of these functionalities are moved to the gateway perspective. And behind AI gateway, um, uh, it is actually the runtime which is handling the model. So you can imagine this to be the downstream systems do not handle many of these common functionalities where these common ones are moved to the gateway itself. The best example would be the token rate limiting, or be it authentication, or whether it is filtering, or even it is guardrails, right? In most of the deployments, people really need some kind of a secure as a security measure to say that, oh, this request can be admitted, or when something is going out, this is a filtered request, I'm not leaking out any information. So people saw a need of having a common place to do all of these things, because all these things are common across all the different models. It doesn't mean you don't need to actually have that in a single model itself, but keep it outside so that people can reuse many of these functionalities for all their workflows.
Yeah, yeah. That's actually a great point. And I mean, as you mentioned it, I was just thinking about it, right? I think one of the differences you called out was essentially how the input and the output lengths are not fixed, right? And then that's how this whole definition came about in terms of defining what a token is, which is also a variable construct. And then the whole billing and assessment has now changed, right? It used to be you call an API, you pay for an API call, but now it's you have all of these additional dimensions. And I think that is what you're speaking to in terms of a layer where all of this is taken care of, right?
Right. So there is something called a gateway API where people wanted all these common things in a single layer than distributing it. This layer can take care of all the common things, irrespective of the model which you are serving.
That makes a lot of sense. And now taking a step back, if somebody wants to get involved in a team building an inference product, right? What do you think they need to bring to the table in the form of skills?
Great question. I would say a strong systems understanding, and that involves your computer architecture itself, in my opinion. So someone who has background in systems, they will have good understanding about how OS work, and how to tune that whenever it is required. Someone who doesn't have that system understanding will find it difficult. The best example would be the OpenAI Triton, where you have a Python interface itself, which can write the best GPU code. So you don't need to worry about your underlying infra anymore, because it's all abstracted out, and you can write Python code, a native Python code. Having said that, when you have a systems way of thinking, you will be able to ensure that you have the best performance coming out of your accelerators, and ensuring your best utilization of the entire hardware stack as well. So in one line, I would say it is the basic systems understanding that will drive primarily all your ML systems research.
I just realized that I never actually clarified what inference was to our listeners. Well, very simply put, inference is just a way of consuming the large language models. And the equivalent in the non LLM world would be an API server, essentially something that just makes it possible to consume these large language models. So, what you're saying makes sense, Johnu. And I think you're also alluding to something closer to a first principles approach to solving things, right? Where you're using the systems knowledge as the building block. Obviously, technology keeps evolving and you can kind of keep learning these pieces.
Yeah, once you have the basics, I think it is pretty easy to adapt. And some of the best people that I work with right now didn't have any experience in Kubernetes or machine learning. They built this entire empire in last 2 years, becoming leaders in the open source and in the product by putting effort. But they had solid systems experience.
Yeah, that's great to hear. I know we spoke a lot about performance, optimization. This will come down to resource utilization and things like that. There's, of course, also the angle of traditional security, which also apply the LLM world. But just to set things apart, most people, when they think about, hey, I want to consume a large language model, I think the first thing we would do is just stand up Olama, like get it up and running on your laptop. You have something that's useful. You can use one of the N open source projects out there for a UI and you're good to go. And by the way, for listeners, I will link Olama and open source projects as well. Now, I'm curious, how is enterprise AI different? How is it different building this for a company?
What you said is absolutely any beginner. I would definitely suggest to get an experience how what generative AI is and how it works. Olama is the best tool for you to get started, and that's the best starter tool in my opinion because you can, without any need of extra infra, you can do that on your laptop and understand what it is, how chat works, etc. Right? But when we talk about enterprise AI, that is slightly different. What you need is actually a production ready system that will add many of these features extra, which is not there in a standalone software product. So it is much more than a standard software installation. You need user management, you need the right RBAC, you need control of the models that you are trying to do in any organization. You need audit trails in order to ensure that what user access and what can be provided back to the user. Monitoring tools for understanding the infra side of things. Am I using the right hardware utilization for that? Or one click, can I deploy a model without worrying too much about the underlying infra? The system has to heal itself and provide a fault tolerant mechanism to ensure that your application experience is seamless. So in a typical installation, you have a data scientist or a ML engineer who actually works on the one layer on top of it, and you have an admin. So you have to cater to both of them. You have two different views. One would be trying to access an application purely through APIs. The other would be a persona who is actually acting on the infra. Both have different set of requirements, and a typical enterprise AI system should provide the right views to both of these personas. So it is much more than a standalone software tool that you typically have in your laptop.
I think between us, we have mentioned a ton of open source projects already in our conversation, whether it's Kubeflow, Kserve, Olama, UI components. What do you feel is the role of open source in just innovation around the LLM area, Gen AI?
Yes, I think in my career, open source has provided me a lot. I'm not sure how many of our viewers will understand that because this is the only way that you can interact with a broader set of people in your day-to-day life. I have learned a lot from the best people or the best tech talent in the world. Be in any company, they will come together, discuss various ideas, implement it, review it. It is not possible to interact and get these learnings otherwise. You would be always in a boxed environment where you think what I am doing is right. When you interact with the open source, you contribute, say, 20% and you get back, say, 40% back. When you write your code, someone is doing a peer review, someone else is doing a testing, someone is doing a production deployment of your code, which is validating what you have done, and you are getting back much more production ready environment. Otherwise, you would have actually employed 10 or 20 people to do the same. So, regarding the tech side and also from a production side, open source is a great bet for you to learn. And the best example is Kubeflow. Kubeflow started as a very small project with 3 or 4 companies. Right now, there are 150 plus companies who have contributed altogether with more than 50,000 commits all in all repositories.
Very well said. And it is phenomenal to see how the open source projects in this area have pushed the boundaries on a lot of this. The other aspect of what you're saying is only because of these open source projects, it reduces the barrier to entry into a field as well, because people now can go and play around with these and also learn. And by the way, those statistics were just stunning. Oh my God, that's amazing to see the growth of Kubeflow, right? Would you have any open problems that you feel like people can start exploring or contributing towards?
I feel AI infra is just a start. It's very dynamic. Every other week, you will see newer techniques in optimizing models and way to solve all the current problems. People talk about all these compact models, very large language models on the other side, right? So you need an ecosystem to hold both the smaller ones and the larger ones in the same stack. And how do you effectively do that? And that's the problem. In many of the use cases, you don't need the world knowledge in every model that you handle. You might be looking at a very, very specific problem. For that, the compact models might be enough. So if you have large connected world of compact models, how can I do the better inference of it? Or if I actually want to build a compact model for my use case, how can I do that with a limited set of hardware? And once we have that, how do I ensure that I'm getting best out of my infra? Right? I see the will become very, very important in the coming years because that's the only way that you can ensure that you're utilizing hardware you have paid for. And you will need multiple hooks to your infra stack so that you get these metrics out and tune the system. I see that to be a common trend right now. What are the right metrics to auto scale and say that your system is performant? Basically, everything from a cost perspective. So there are multiple problems in this space when we are looking at these models, and it is still evolving. We have to be dynamic and see what the problems are and provide solutions that can help in the current use cases that we see.
Yeah, I think that's a very interesting one. And it is a very exciting space just in terms of the pace of innovation in this area. I know we are hiring as a team. So, do you want to say a few words about the roles we're hiring for?
Sure. We are always looking for the best AI systems team, and we have an amazing team here in Bangalore. We would like to bring the latest research that is happening in the system side of your machine learning and provide that back to the customers that we have. And from the skills perspective, as I said, someone who has actually built large scale systems, who can understand systems, I think that's the only thing that we are looking for. Rest all things in my mind can be mentored and then can be developed over time. You have to have the operating systems knowledge and what to apply and when to apply and how to debug. And rest all things can be easily built on top of it.
Awesome. Plus 100% on the phenomenal team, by the way. Do you have any parting thoughts, Johnu?
It's a very dynamic space. So I think we have to constantly innovate than the traditional softwares that we have, where we have visibility into next 5 years what the roadmap would be. But in the current AI world, that is not possible. Today, Llama 3.3 is there. Tomorrow, Llama 4 might come in with a different set of challenges. Llama 3 came in with 405 billion model, which was not there before. So what I tell my team is, uh, rather than thinking how world will change tomorrow and whether jobs will replace humans, just act now and be part of it. Else, at a later point, you will regret that, oh, I missed this opportunity. So be part of it and then start executing than thinking whether I'm at the right time. You are there.
Yeah, I think that's a great thought to take home because you don't know what the future holds. And so you can't obsess over those things. This was phenomenal, Johnu. Thank you so much for doing this interview with me.
Thanks, Ashwini, and thanks for hosting it.
Thank you for listening. If you enjoyed this episode, please like and subscribe to our channel on YouTube or on any podcast platform. Follow us on LinkedIn at Through the Corporate Glass. You can leave us a comment on YouTube or send us feedback via our website, throughthecorporateglass.com. We would love to hear your feedback.